I was having fun. I went to Bentonville to meet my very close family friends, and that's the reason why yesterday we could not meet. But whatever we were supposed to do yesterday, that we'll do on the coming Wednesday as a makeup class for you all. Hello, Savia. Can everybody hear me okay?
Yes, sir.
Okay. So let's get started. So here in the classroom, it was only Praneeth and me so far. When we got one more child in the class, I found the child is okay, right? Yeah. Okay. Your name I forgot. Alekia. So today we are going to do what? Last class, if you guys remember, we were talking about center, spread, and distribution of numbers. Correct? So we will continue on that, on the same journey. And let me quickly check if, yeah, it's fine. So we touched upon mean median mode, and I happily wasted everybody's time, 45 minutes, because this is something that you all know and you all knew. There's nothing new that I kind of taught you guys, correct? Anybody having a different point of view? I did not teach you guys anything new. What I was trying to make you guys believe is that when you, yes, Vishal.
Does the class still at 5? Does it end at 5?
No, it ends at 4:50. Oh, 5 as in you are in Eastern time zone, right, Vishal?
Yeah, for us, yeah.
It'll be ending at 5:15 because we started 15 minutes late. I just reached home 5 minutes ago. Okay, so I'm not even changing my clothes.
Okay.
I'm still a traveler. All right. So we talked about mean median mode, and we tried getting a different perspective. Why we even need to learn about mean median mode? How does it actually make a difference in our life? Anybody wants to give a quick commentary of what we learned, or what is the extra perspective that you guys built, or you just want me to get started with my narrative? Nobody has to be shy. Yes, Narka. Okay, so let me do a quick recap of what we learned so that there's a continuity with respect to what I'm talking. So we talked about what is mean, what is median, and what is mode. So when you talk about, here let's say I have 6, 8, 10, 12 and 9. They are 5 numbers. Can everybody see what is written on the board? Ria, okay beta?
Yes, sir.
Okay. Alright. So here I have some numbers. By trying to find out center, spread and of the distribution, or trying to find out mean median mode, it's nothing but it gives us the ability to interpret the data. Look at the data, derive some meaning out of it, and then make your mind, okay, if I have only 5 numbers, imagine if I had 2 more numbers, what possibly those numbers could have been. It gives you the ability to predict or forecast what you don't see here on the board. So that's why we learned that mean median mode, and if I do a quick recap, mean is nothing but average. Meaning you will add these numbers and divide that by, since you have 5 numbers, divide that by 5. That gives you the average. So let's say if this average comes out to be 9.4. Now if somebody asks you to predict what the 6th number would be, you will say, okay, my number would be probably in the range of 8 to 12. You would not say 99 because that has no relationship with what you have here. That doesn't connect the dots with respect to what you're seeing here. Okay? So that is the mean. Now, median. How do you find out the median of this number? Does anybody remember?
You would organize it from least to greatest, find the middle. If there's like not
Okay.
a middle number,
I'll come to you, Nikhil. Okay, I'm just hearing something.
If there's not a middle number, you take the 2 numbers there, add it, and find the average between those 2 numbers.
100%. Okay. Yes, Nikhil. Teacher. How do you?
It's like the number that's in the exact middle of the entire data set, which means like you have to order it from least to greatest and then find the exact middle number.
Mm-hmm.
And if it's even, then you have to find the average of the middle two numbers.
Okay. Now let me put some people on the spot. So Nikhil said, and Lakya and Pranit also said that you arrange them and find out the middle number. If I had 5 numbers, meaning odd number of numbers, then I could find out the middle number. If I had even number of numbers, let's see if I had 13 also, I have even number of numbers, then what I'll do is I'll still arrange them in the increasing order and then look at the middle 2 numbers and find the average of that guy. Now, Lorian, now I want to flip the story for you guys a little bit. Ria, would it be okay, beta, if I instead of putting them in increasing order, if I put them in decreasing order, will the same approach work?
Yes.
Yeah.
Okay. So I wanted to make sure that we don't go with one narrative that it has to be increasing order. No, it has to be ordered numbers, set of numbers, and then you look at whether I have odd number of numbers or even number of numbers, so that you can find out the middle one. Yep. Everybody with me? Dave, Neil, Sarah, everybody, right?
Yes, sir.
Ritika, any doubt, beta?
No, sir.
Okay, wonderful. Now, so we saw mean. Mean is nothing but average. I know you guys will say my teacher is mean. That has a different meaning altogether. But this mean is nothing but the average. Yeah. So we know what is mean, and we just saw what is median. Again, you look at this. Median also, if I'm talking about, let's say if I'm talking about these 6 numbers, how will I find out the median? Like the way you guys said, I'll put them in an ordered way. 6, 8, 9, 10, 12, 13. I have these 6 numbers. The way you guys explained me, how many numbers I have? 6. So I don't have a middle number as such.
9.
I will just look at these 2 numbers, add them together, find out the average of that, which gives me 9.5. Now if you look at 9.5 here as a median, if you look at it carefully, what do you see? The smallest number is 6. The largest number is 13. What's the difference of this median with the endpoints? Here from this guy it's 3.5 different. From this guy also 3.5. I mean, this will not be the case exactly always, but it tells you that this is kind of a center of all the numbers that you have. Likewise, if you look at the average also, the mean will also give you somewhat closer to this. Let me do that real quick. 6, 8, 14 plus 9, 23 plus 10, 6, 8, 14 plus 9, 23 plus 33, 45, 58. 58 divided by 6. 6, 9 ja 54, 4 zeros, something like this, 9.66. See, that is also closer to this guy. So whether you find the mean, whether you find the median, you see similar behavior. It tells you what kind of average, what kind of central behavior of the data that you are seeing. Is everybody with me? Vishal, Dhanushri, Ritika, everybody?
Yes, sir.
I'm randomly calling out names. That doesn't mean I'm trying to put anybody on the spot. I'm just trying to make sure that I'm not making anybody sleep. Yeah? Everybody with me? Shriyam? Shriyam with me?
Yes.
Okay.
Yes, sir.
Alright. So we saw that, okay, beat mean, beat median, these things are not just a calculation mechanism. This gives you the ability to make some interpretation out of the data that you see. Trust me, data, look at these numbers which look pretty dumb by itself, has a lot of hidden information underneath. That's why when I started my career in the IT field, there was nothing called data science. Okay? But with IT system maturing more and more with time, nobody talks about coding these days. People talk more about data science because they found that this is like a mine. More you dig, more insight you get, and that helps you make great decisions. So that is why all these things that we are doing, even if it looks pretty, a known thing, very easy calculation, but they have lot of insightful information that helps you make decisions. Now look at this. Forget about all the data that you're seeing. Imagine somebody recording. Yes, Nikhil, saying something better?
No, sir. I think it's glitching.
Okay. But everybody can hear me okay, right?
Yes, sir.
Okay. I mean, if I'm glitching, let me know, okay? Alright. Now, forget about this. And you will say that, no, these are the things that we know since our childhood days. And we are grown up now. But still, there are a lot of things that we have not looked at from a different perspective. Now let's look at it. If I say May has just started. So on 1st of May, the temperature in Mikini was, maximum temperature was 58 degrees Fahrenheit. 2nd of May, it became 65 degrees. 3rd of May, it became 68 degrees. I'm talking about the maximum temperature, okay? Then 4th of May, it was 69. Again, on 4 days, 56 degrees. And then let's say 7th of May, it was 49 degrees. I'm just making it up, okay? Then 68 degrees. Here, when you look at this set of data, 7 days of temperature, maximum temperature, is there anything interesting or meaningful that you can derive from this? Any interpretation?
The range and mode.
Range and mode. Okay. Assume for next 5 minutes that your teacher is not intelligent, neither you are. Let's be normal human being. We don't have to think that, okay, we are dealing with math. Look at this as a normal human being. Okay? Yeah.
The temperature is like unpredictable. It goes up and down like up and
Yeah. So there's one more interpretation that's coming as temperature is very unpredictable. It's going up and down. How does it matter to you?
Not really effective.
Doesn't matter. It matters to me a lot. I'll tell you why. Okay, let's see. Any point of view from the screen. I have put the temperature for first 7 days of May. And you guys, I just want to build that perspective among you all, okay? How does it matter to you? I mean, what would you do with this information? Anything creative?
we can plan what we're doing for the day based on this.
Okay. Yep, Nikhil.
I could try predicting what temperature might come.
Okay, you're saying that for next 2 days I'll try predicting. Okay, makes some sense. Okay. What else? Yeah.
Planning my outfit for what to wear.
Interesting. You'll plan your outfit for this one. Okay, that is another one. How does it matter to me? See, my wife has been. Okay, yeah, Vishal, go ahead.
I can find like what would be the average for the rest of the days.
Okay. See, my wife has been after me saying that okay, winter is almost over and we have not folded the blankets and kept it inside. Now, how does it matter to me? I'll say, no, wait. Temperature is still fluctuating. I'll delay that plan of folding and putting the mattresses back or the blankets back by maybe another week or so. I'll say, okay, I see this is fluctuating. It might become 49 again or 47 again and then be cold. We need to have the blankets outside. If I fold it and keep it inside and put it in my attic, it's going to be horrible. So, all this information, right, if you look at this, some of you said, okay, we'll plan outfits. Some of you said that, okay, I can predict the temperature. Some of you who have to plan for buying even sunscreen. Maybe you don't have to rush for buying sunscreen. It's okay. I mean, the temperature is still bearable. It's not going to hurt. So, there are a lot of things. The same data means different things to different people. And even after you keep aside the math part of it, this has a lot of things into it. Imagine how would it matter to somebody like Walmart of the world, the Targets of the world. They will still not keep the sunscreen thing in the front of the aisle. They will rather keep the things that keep people warm in the front of the aisle. Because people still, some unprepared like people like me, who has folded the blankets and kept it inside, I might rush for buying one wind cheater actually. Yeah? So that can still be sold. So the same data to different people means different things based on what their perspective is, and that's why understanding data is very, very important. So the mean and median thing that we talked about, we could at least relate it to practical relevance in our life, right? Is everybody with me so far? Dhanushri?
Sure.
Okay. So yeah, somebody saying something? Alright. So this is the relevance that we could draw from mean and median. Now what is mode?
Most popular.
Most popular. Okay. And so anybody on the screen? What do we mean by mode? We have learned how to find out the mean. We have learned how to find out the median also. And you guys thankfully found a very mean teacher also. So what else do you need to find? Why we even have to worry about the mode part of it?
Because say there's like a lot of one number, this can affect your average, your median. Everything's affected by all the numbers there. So if you have multiple of this number at one point, it just becomes the data set.
Okay. Yes, Nikhil. Tell me, why do we even need to bother about mode? I mean, what is mode in the first place, and why do we need to bother about it, and how does it actually help? Yeah, Nikhil, go ahead.
Mode is the most common occurring data point in the set, and it's important because if you study the mode really closely, you can figure out what, like for example, if most people are buying some certain product, then companies can use the mode to figure out if they should up the prices or something like that.
Yeah, that's a very predictable, that's a very relatable example. Anybody else having a different point of view or something that you want to share? Don't be shy. Nobody has the option of being shy in this class, okay? As long as you are not shy in front of your parents, you don't have to be shy in front of me. And nobody should be shy in front of their parents, right? Yep. Okay. Anybody? Shriyan, you have been very quiet. Any different point of view? Or
I agree with what Nikhil said. Basically, like a company, they can see what's like the most occurring thing that people are buying, and they can maybe sell more of that, or up the prices on it, or manufacture more of those things.
okay. Sunarka and Rehan, any point of view? Sometimes you guys have to challenge your teacher also, okay? I would be very happy when you guys prove me wrong. Sometimes, not always, sometimes. Once in a month. Yeah? Okay. So now let's look at it. Mode, as most of you said, mode is when you're looking at a data set, number of records that you're dealing with, number of data points that you're talking about. Mode is the most occurring record or information in that data set. And that helps you predict. Another thing that you might want to think is the mode has maximum influence on the trend of the information. Right? Let's look at this. If I have, let's say, 13, 16, let's say this is the age of kids in a class. I know this, you don't get to say this kind of range, but let's see this. Now you look at, this is the age of kids in a class. Okay? So you have some, in one grade, let's say. This is, let's say, 10th grade or 11th grade. Okay? I'm just making it up, okay? I might be completely wrong with my assumptions. But here, one kid is 13-year-old, other kid is 16-year-old, 12-year-old, 13-year-old, 12-year-old, 18, whatnot. So what we see here is 13 has how many occurrences? 3. We see 3 of 13. 2 of 12. The rest all are only ones. Imagine if this is the team that is going to participate in a sports event. I was saying that this has maximum influence, meaning teacher will think that okay, the teacher has to go and buy jerseys for them all. That's okay. Most of my kids are in this range. If I buy something which is fitting the kid who is 13-year-old, I'm taking care of majority of the group. This guy, these two will also probably align with this one, right? So here, 5 of the kids are taken care if you just buy a jersey which fits a 13-year-old kid. 1, 2, 3, 4, 5 you have taken care. Out of how many? 18. 5 out of 18. 5 out of 8. Almost more than 60%. Yeah. So this influences. If you say, okay, I'll buy all the clothes which fits 18-year-old kid, you'll be grossly wrong. So here, mode is, as you guys know and as you guys explained, mode is nothing but it's the data which is occurring maximum number of times in the given set of data that we are talking about, and then it has maximum influence on the overall behavior of the data or the trend. If you still want to do calculation, find out the mean and median, you will see that mean and median will be very close to this one because this is influencing the overall central behavior of the data. Make sense? Does it make sense?
Yes, sir.
Okay.
Yep.
Alright. Now there's one more thing. And these are kind of little subjective still in nature. Okay. There's a more accurate way to find out the overall behavior of the data. That's called standard deviation. Now, who all remembers how to calculate standard deviation? Kind of.
Yeah.
Nikhil, you remember?
Yes, sir.
Sian, you also remember?
Yes, sir.
Okay. So, we'll do the calculation part now. But in summary, standard deviation is nothing different. It just helps you find out the trend of data in a more scientific way. It gives you a more mathematical reasoning around the trend of the data. Let's say if I'm talking about 6, 8, 10, 12 and 19, okay? And then I'm talking about 6, 8, 15, 19 and 20. You might get mean closer to this one. In both the cases, the mean or the median might be closer to in both the cases, but the standard deviation would be different. We'll just take a look at that and see how that helps you interpret the data in a different way. Yeah, Nikhil, you're saying something.
No, sir. I don't know. My microphone is going like really weird today.
No worries.
I'll join it. I'll leave me.
Okay, you can drop off and join again. That might help. Yeah. Okay. Neil and Sarah. Any question, beta?
No, sir.
Okay. Now let's look at how do you calculate standard deviation, and then we'll look at a data scenario to see how does it actually matter. So let's say if I have, this time we'll take a probably smaller number. A smaller set of data. I have these 4 and I'll probably pick up this also so that my job becomes a little easier. After driving 5 hours, 5.5 hours non-stop, I'm trying to be a little lazy. So I have a set of record 5 data points. What is the mean here? 8. Because you can see that all sequential and same difference, right?
Not the mean.
Mean will also be 8.
Okay.
Look at this, 4, 6, 8, 10, 12. So every number is increasing by 2. So if you calculate it also, 4 plus 6, 10, plus 8, 18, plus 10, 28, plus 12, 40.
yeah.
Gives you 8 as a mean.
Yeah.
Yeah. Mean is 8.
Median's
Median is also 8. Is also 8. Everybody on the screen with me? Rehan, Ria, Ritika.
Yes.
Okay. So by looking at this data, we got mean as 8, median as 8. Now, there's one more thing that we need to know, or which I have not talked about, that is called range. That range tells you what is the difference between your smallest number in the data set versus the largest number in the data set. So here if you look at range, that is
8.
largest number is 12, smallest number is 4, which is 8. Now how do you find out the standard deviation? Standard deviation is nothing but the average of the square root of difference with the mean. So your mean is what? 8. So if you have to find out the standard deviation, okay? So standard deviation would be nothing but you have found the mean. So what you will do is you will say square root of what? 8 minus the first number. 8 minus the first number, square of that, plus 8 minus the second number, square of that, plus 8 minus the third number, square of that, plus 8 minus the fourth number, square of that, plus 8 minus the last number, square of that. So, and square root of the whole thing divided by n, how many numbers you have. Is this n inside this one or it is outside the square root? Anybody who remembers the formula right now? I'm sorry? Inside? Okay, we'll see. Do you guys remember the formula for standard deviation? So we had some numbers, we found out the mean, and we tried to find out the standard deviation. The standard deviation formula is nothing but the difference of the mean against each number squared divided by n square root. I just probably don't remember whether this n is inside this square root or not. Just check it offline, okay? But here, the overall behavior would not change. Yes, Nikhil.
This is different than mean absolute deviation, right?
This is mean absolute deviation, yeah, that is different. This is standard deviation. Where you do a difference, square of the difference, find out the average of that and do a square root of that. So that gives you a more granular detail with respect to how your data is fluctuating. Okay. A quick question to everybody, because everybody is quiet. Who has come across standard deviation in the past? Okay. Yes, Nikhil has come across that. Anybody else? Yeah, Chris. Okay. Yeah, Vishal, tell me.
What?
Yep.
Oh, I thought you were asking who came across standard deviation.
Okay. All right. So, yeah, Chris. So everybody is just raising their hand to acknowledge that yes, it is. You guys have come across it. Yes, Dhanushri. Okay.
I came across it too.
Yeah. Okay. So I'm assuming that everybody has come across this. Now here, what I wanted to confirm you guys that this n is inside the square root. Okay. This is inside this one.
Is that pi?
No. This n is nothing but a number of elements you have in your this thing. Yeah? Is everybody with me so far? So, simple thing is this. The standard deviation is a more accurate way to find out the trend of the data. And we'll look at this, okay? I'll give you an example. Right now, I'm just forcing you guys to memorize this formula. This means nothing but, the formula is, you find out the mean minus every number squared, and then you take the average of that, and then you take the square root of that whole thing. So let's calculate this one right now, okay? So here we have 5 elements in this set of data that we are looking at. So what is that coming to? It's 8 minus 4 square is 16, plus 8 minus 6 square is 4, plus 8 minus 0 square is 0, plus 8 minus 10 is minus 2 square is 4, 8 minus 12 is minus 4 square is 16, divided by 5. So this gives you 16 plus 4, 16 plus 4, 40, divided by 5. That gives you square root of 8, which is 2 square root. Square root 2 is nothing but 1.414 if I'm not wrong. So this gives you 2 into 1.4. I will round it to 2 into 1.4 is 2.8. I got standard deviation is 2.8. Okay. Now, in this case, so you guys have seen the formula just now. Now, let's look at, we got standard deviation is equal to 2.8. Now let's play with this little bit. Yeah, Dhanushri and Nikhil, are you guys saying something?
No, sir.
Okay.
I
Now,
think my microphone might be weird again.
no worries. I'm sorry, Vita?
I think my microphone might be glitching again.
Oh.
I'll really.
Don't worry about it. As long as you can hear me, I'm good. Now, 4, 6, 8, 10, 12, we found the standard deviation is this much. Okay. Now, let's do one thing. 1, 2, 3, 4, and 5. Here, we got standard deviation is 2.8. Okay. Now, in this case, one thing that you can see here, the difference between every number is 2. Okay. We got standard deviation 2.8. For this guy, what is my standard deviation? So my mean is again 3. What will be my standard deviation? Will be nothing but square root of 3 minus 1 square. This is 2 square. I'm just doing a little faster. 3 minus 1 is 2. The square of that is 3 minus 2 is 1. Square of that is 1. Plus 3 minus 3 is 0. 3 minus 4 is 1 minus 1. That is square of that will be 1. And 3 minus 5 will be minus 2. Square of that will be 4. Divided by 5. What did we get here? 4 plus 1, 5 plus 1. Plus 4. That is 10 by 5. What did we get? The square root of 2. Which is nothing but 1.414. Now look at this number and this number. Numbers are changing quite a lot. I mean difference between this one and this one is that the case. Now let's take one more example. Let's pick up a number where we are seeing more variance. Here it was 1.414. Now let's pick up a set where we have 13, 2, 9, 17 and 50, not 54, let's say 21. So here what we're trying to enforce is, or what we're trying to check is this. Come on. Okay. So here what we are trying to check, in this case the difference between the numbers were much more controlled. Here it was even less. I mean much more controlled, meaning we are seeing less difference between the numbers and my standard deviation is coming down. Here when I have a range of numbers fluctuating way too much, what would be the impact on standard deviation? This should be much higher than these two guys. And we can check that. So here 13, 2, 9, 17, 21. This is 38 plus 9, 47 49, 62. 62 divided by 5, that gives me 12.4. This is my mean. Now, my standard deviation would be square root of 12.4 minus 13, 1.4. 1.4 square. 12.4 minus 2, that gives me, I'll probably try to do away with some rounding, okay, so that we can do it faster. So 12.4 minus 2, 10.4 square plus 9 minus 12.4, 3.5 square, 3.4 square plus 17 minus 12.4, 5.4 square plus 21 minus 12.4, almost 8.6 square divided by 5. Now look at this one. 1.4 square gives you almost like 2 plus 10.4, 100, maybe 101. 3.4, it's less than 16, 9, between 9 and 16, I'll say 12. 5.4, 25, maybe 28. This is 8.6, 9, 81, little less than that, maybe 75. Divided by 5, look at this. 103, 115, 143, 200, maybe 220, 43, 148, 280 by 5 square root. What is this one? This is almost like 5, 4, 48. So square root of 48. What do we see? Almost like 7, nearly 7. See, this is not the mean. This is certainly not the mean. Your mean in this case is 8. In this case is 3. My standard deviation is nowhere close to the mean or median of the number. It just tells me how much is the fluctuation among all the data elements that I am dealing with. See, here fluctuation is more compared to this guy. But here, in this case, my standard deviation is much higher. So higher the number, higher the difference between your numbers, higher the domain that you are talking about or the range you are talking about, higher will be your standard deviation. Now look at this situation. If I am talking about one last example, okay. Is everybody with me? Rehan, Ritika, Dhanushri, Shreyan, Sarah, Neil, everybody. Now I have a question for you guys. If I'm talking, let's say I'm talking about 8, 8, 8, 8, 8. What will the mean and median? 8. Okay. What will be the standard deviation here?
Like 8.
What will be the standard deviation here? Everybody. Okay. Let's see. I'm just making you guys think. I'm talking about data elements like this. What will be the standard deviation in these cases? Okay. I'm just letting everybody think. Yeah, Dhanvin, tell me.
Is it 0?
I want to hear it with more confidence.
Okay.
Yeah, Nikhil.
I also agree that I think it is 0.
Yeah, see, first of all, don't get trapped in the terminologies. We are talking about deviation. Do you see any deviation among these numbers? No. Your mean and median is nothing but the average. That will be different for these groups. This will be 8, this will be 9, this will be 50. But standard deviation, as the definition or the English meaning of that is deviation among the numbers. Is there deviation? No. There is no deviation, that is 0. Now you can calculate it also. Let's quickly take a look at it. Stanley, you want to learn standard deviation today? Stanley, you're a little early bit, okay? So, all the kids from level 1, we started a little late because I was traveling. I came home just now. So, we'll start your class a little late. So, 4:15 is when we'll start for level 1 kids, okay? So we have probably 15 more minutes, okay? So have some more fun. We'll meet you guys at 4:15. Meet you guys as in the kids from level 1, okay? Alright? Alright. So coming back to this one. Now if you have this number, or let's say if I have a set of numbers 101, 101, 101 5 times or 10 times. What will be my standard deviation? Okay, we see that my mean is nothing but 8. If I try finding out standard deviation, I know that my standard deviation is nothing but square root of this guy's difference with every number. 8 minus 80 square, 8 minus 80 square, 8 minus 80 square, 8 minus this 8 also 0 square, 8 minus this 8 also 0 square. You want to divide this by n, or you want to divide this by 5, you want to divide this by 500 or 5 million, doesn't matter. You are dividing 0 by some number. What you are getting is 0. Now, what does it mean? You see that there is no deviation. Every number is same. That's why my standard deviation is coming at 0. Now, let's play with this a little bit. Let me put this as 9. Then what will be my deviation? My mean would be probably 8, 4 the 32 plus 9, 41, 41 by 5 gives me 8.2. Yeah. So this, what will be the change to my standard deviation here? This becomes 8.2 minus 8.2 square. This is also 0.2 square, 0.2 square, 0.2 square, and then 0.8 square. 0.2 square is nothing but 0.04, 0.04, 0.04, 0.04, and then 0.64. Yep, divide by 5. This became 0.16 plus 0.64, 0.64 by 5 square root. This became 0.8 by 5 square root, which is 0.16 square root, which will be 0.04. See, look at how small is standard deviation here in this case. Because since you don't have much of fluctuation, hey Mandeep, you joined 15 minutes early, beta, okay? Your class will start at 4:15. I'm teaching standard deviation, which might be just a little too much for you, okay? So you might want to join at 4:15, Mandeep. Okay? Yeah? All the kids from level 1.
Me?
Yeah, Mandeep is you only, right?
Yeah.
There's no other Mandeep. So all the kids from level 1, request you guys to join at 4:15. We are starting a little late today, okay? Alright? Yeah. Shanvi, you also better. Join at 4:15, okay? So what we see here, the standard deviation gives you a much, it is nowhere close to your mean or median. It is just a number by itself, which tells you, with one value, tells you how much of fluctuation you are talking about within the data set that you have. You can play around with this one. I'm always picking a set of data elements with 5 records into it, but you can pick 3, you can pick 30 also, depending on how much you want to play with this. But net, it helps you derive the behavior. See, since I'm changing only one number, everything else is close to this. If you change this 9 to 19, this might change. But your overall, it will still depict the overall behavior. So net, your standard deviation is your yardstick, which helps you determine, with one value, it tells you how much of a fluctuation you are looking at in the data set that you have with you. Is everybody with me?
Yes, sir. No.
Okay, so I want you guys, we have 15 minutes, I want you guys to get your hands dirty, right? It should not be that, okay, only the teacher gets his hands dirty after the class gets over. See how dirty my hands are. I want you guys to get your hands dirty as well. So let's find out the standard deviation for 2 sets of records. I have 18, 16, 0, 9, 15, 17. Okay. And this is one set of data. And second set of data is 9, 2.6, 9.1, 2.5. I want you guys to find out the mean, median for both the set of records and also standard deviation in both the cases. And give me a story with respect to how you interpret that. Yeah. So kids from level 1, your class will start at 4:15 because we are starting a little late today. So you guys can join after 15 minutes, okay? So yeah. So for the level 3 kids, we have two set of records, 18, 16, 0, 9, 15 and 17. That is the first set. Second set of record is 9, 2.6, 9.1 and 2.5. I want you guys to find out the mean and median of these two sets and also the standard deviation. I will let you guys deal with it for next 5 minutes and then we'll start. So today we are starting the class 15 minutes late, okay? So you can go and sit inside, but your class will start 4:15. Daddy will come at 5:15 to be here.
5:15 to pick up. You want to sit over here or you want to sit over there? Okay.
Okay, any station. Just move this card out. Okay, who all are done? Yes, Ria.
I'm done with the first one.
Okay, tell me what the answers are.
So the median is 15.5
Okay.
and the mean is 12.5.
Median is 15.5 and mean is 12.5. Okay. How about standard deviation?
I haven't done that one yet.
Okay. Finish it, then we will talk. And again, I'm kind of making you guys do that because when you do mean, median, and then the standard deviation, then you can see that starking difference between them. Okay. At times, what happens is you might get biased that okay, mean, median, and standard deviation are the same thing, but they're actually not. Mean and median tells you the average part of it or the center of this, and standard deviation tells you how much of fluctuation you are seeing in the data that you're dealing with. Sami, you are early by 7 minutes beta, okay? 8 minutes actually. We will start your class at 4:15.
Okay, sir.
Okay. Yes, Vishal.
For the second one, I got median as 5.8,
Uh-huh.
and I got the standard deviation as around 3.2.
Okay. How about the first one?
I didn't do the first one.
Okay. Yeah, Nikhil, go ahead.
I finished the first one. For the mean and median, I got the same things.
Uh-huh.
But for the standard deviation, I got 6.29 or 6.3.
Okay. Okay. Anybody else who is done? And again, trust me, I'm not in a hurry. I'm not trying to rush or not trying to create pressure on you guys to finish it. I'm just trying to see that based on whatever you guys are doing, are you able to derive interpretation from that the way we looked at it? See, when okay, I'll probably give you guys 2 more minutes and then I will give my speech. Neil, Sarah, are you able to try better? Rehan?
Yes, sir.
Okay. Sunarka, Shreyan, sorry, not Shreyan.
For the first one, my standard deviations are around 5.8.
Sir, can I change my answer?
Okay, yeah, tell me.
Can I change to 6.29 for standard deviation?
6.29 you are saying?
Yes, sir.
Okay.
I got about 5.5.
5.5 for this one.
And my mean median are the same.
Okay. How about this one?
I have to.
Okay. Yeah, like how about you, Vida?
You got the same things.
You're the same?
I
Okay.
didn't do it nicely.
Okay, that's fine.
I'll answer.
But you know what? I always want all the kids to, and I call you guys kids, which you don't like, but that's okay. That no, when I see you guys doing this rough work, that gives me more confidence because no, when you guys do that, right? That's when you get more comfortable doing it, and that remains in your memory also.
Yeah.
Well, I've seen kids say, okay, this person, this, and yeah, my answer is this. No, that calculation error doesn't hold any water. So Hina, we'll start your class at 4:15 beta, okay? So I'm just wrapping up the class for the senior kids, then we'll start your class, okay? Yep. Alright, so let's make sure that you guys stop here. We have just 4 more minutes. And I will go with the assumption that you guys know how to do the calculation, and if somebody forgets how to do the calculation, you can always watch the video of the class and then revise that. But what is important for us is how do we wrap our head around what we are seeing here? If you look at this data and this data, if I want to make a blind guess, I will say that for this guy my standard deviation would be more. Here my standard deviation would be more compared to this guy. Because here I see it's ranging from 0 goes all the way to 18. Yeah? Sit down. It's okay. Wherein here you are, no, everybody sit down. It's okay. We have enough space for everybody. Sit down. Here if you see, it's starting from 2.5 goes till 9. So my range is between 2.5 and 9. I'm talking about a deviation of 6.5 against the smallest value of this or against the largest value of this. Wherein in this case, I'm ranging from 0 to 19, 0 to 18. So my range is this. My smallest number is 0. My largest is this one. If I'm looking at the mean of this one, probably I'll range somewhere between maybe 9 and 10. Whatever you guys got me, right? 12.5. So my 12.5 is way too different from this guy and significantly high from this guy. Whereas if you look at this one, your average or the mean came somewhere around 4.5 or 5, right? Maybe 5.3. Yeah. So just by looking at the data, you can say that okay, here my deviation is less, here my deviation is more. So whatever be the method for calculating standard deviation, this will give me a higher standard deviation, this will give me a lower standard deviation. If I look at that just as a consumer of this data, I can see that okay, here I see more fluctuation, here I see less fluctuation. That fluctuation is nothing but a mathematical representation in the form of standard deviation. With that being said, anybody having any conceptual question around what we have done so far? No? Everybody is tired of me already? I'll let you guys go. Enjoy the rest of your evening.